Hello Cloud Gurus, and in this lecture we're going to cover the overview of Security Processes white paper. This is pretty much the most important white paper for the exam, and I did say that you wouldn't have to read any of the white papers, but I do strongly recommend that you read this. I've gone through it myself and I've just pulled out what I think are the key salient points, but it's probably worth going through this white paper just before you go into the exam. It is 75 pages, but skim through it. I hopefully have captured the most important points in this lecture, but if you do find something that I haven't captured, please let me know. So if we have a look at the exam, if you remember the exam blueprint, 60% of the weighting was designing highly available, cost-efficient, fault-tolerant, scalable systems. We've covered that off in great detail. We've done implementing and deploying. We've done a bit of troubleshooting whenever something's gone wrong on my screen. Really this is the data security piece. So data security can encompass your VPC. We have covered a lot of it off. How we configure your VPC, your different subnets, your different access control lists, your different security groups, how you can apply an access control list across an entire, 2 or 3 different subnets and encompass all your security groups inside that access control list. So we have covered that off, but the rest of the data security stuff really comes from this white paper, and I have put a lot of exam questions in and around data security in our practice quizzes, so hopefully you'll find those beneficial. So the key points, I thoroughly recommend that you read this white paper as it covers 20% of the exam, but I will summarize the key points in this lecture. So as you know, Amazon offer a shared security model. We have covered this briefly in the past. But AWS is responsible for securing the underlying infrastructure that supports the cloud, and you're responsible for anything you put on the cloud or you connect to the cloud. So if you have a look at this diagram, you can see that AWS are responsible for their global infrastructure or for the platform or infrastructure as a service, but then you are responsible for your S3 security, your EC2 security, your VPC security, your RDS security, your workspaces security. So that is a customer responsibility. So it's a shared responsibility model. Amazon Web Services is responsible for protecting the global infrastructure that runs all of the services offered in the AWS cloud. This infrastructure is comprised of the hardware, the software, the networking, and facilities that run AWS services. AWS is responsible for the security configuration of its products that are considered managed services. So I mentioned infrastructure as a service, and we were really talking about up to the hypervisor level, and then you're responsible for like EC2 for the operating systems. That is the case unless it's a managed service. So examples of these types of services include Amazon DynamoDB, RDS, Redshift, Elastic MapReduce, Amazon Workspaces, etc. Now, if you remember when we were doing the database section of the course with Amazon RDS, you are literally just getting an instance, a database instance in the cloud. You are not responsible for managing the underlying operating system of that instance. You don't need to worry about patching, etc. Amazon do that for you, and that's really called basically it's almost application as a service, what they're offering. You don't need to worry about the underlying OS. All you need to do is worrying about securing your application as a service. So infrastructure as a service such as Amazon EC2, Amazon VPC, and Amazon S3 are completely under your control and require you to perform all the necessary security configuration and management tasks. Managed services, AWS is responsible for patching, antivirus, etc. However, you're responsible for the account management and user access. It's recommended that multi-factor authentication be implemented, and you communicate to these services using an SSL or TLS encryption point, and that API users and API or user activity is logged and set up using CloudTrail. If you remember the difference between CloudWatch and CloudTrail, CloudWatch is monitoring, CloudTrail is logging, and that is an exam question that can come up. Talk about storage decommissioning. This does come up in the exam, and also customers do like to know what happens when you decommission storage. There was a couple of years ago a sort of an incident where it was found that companies weren't disposing of their storage properly, so that when you terminated an instance, and then if a customer then reactivated or spun up a new instance, they could use forensic tools to recover what was on that instance previously. That happened with a few cloud providers. Not going to name names, but it is a matter of public record if you want to Google it. Just Google disk zeroing in the cloud. So that has now been addressed, and most, all public cloud providers, as far as I know, are now secure. So we talk about storage decommissioning. When a storage device has reached the end of its useful life, AWS procedures include a decommissioning process that is designed to prevent customer data from being exposed to unauthorized individuals. AWS uses the techniques detailed in DoD 5220.22-M, which is the National Industrial Security Program Operation Manual, or NIST 888, Guidelines for Media Sanitation, to destroy all data as part of the decommissioning process. All decommissioned magnetic storage devices are degaussed and physically destroyed in accordance with an industry standard practice. So they don't just wipe the disks, they then go on to physically destroy them. Talk a little bit about network security and different transmission protection. So I sort of mentioned it earlier, but you can connect to AWS using HTTP or HTTPS. For customers who require additional layers of network security, AWS offers the Amazon Virtual Private Cloud, which provides private subnets within AWS and the ability to use an IPsec VPN connection or device to provide an encrypted tunnel between the Amazon VPC and your data center. So your users can connect to your web servers using HTTPS, but then if you want to then have subnets inside your VPC that are not internet facing and that are on an internal IP address that only you can access from your from your office locations, you can configure that. You can use Amazon Direct Connect or Amazon Gateway Services for that. Another question I have, actually, this came up in my exam about corporate segmentation or segregation. Logically, the AWS production network is segregated from the Amazon corporate network by means of a complex set of network security and segregation devices. So I think in my exam it said something like, is the Amazon.com network the same as the AWS network, or something like that, and you just say no, it's segregated. Talk about network monitoring and protection. So Amazon provide by default DDoS mitigation. They do protect against man-in-the-middle attacks. They protect against IP spoofing. They protect against port scanning. We'll explore that in a little bit more detail. They stop packet sniffing by other tenants, so can't do packet sniffing to see what's open. In terms of IP spoofing, so there's an AWS controlled host-based firewall infrastructure, and it's not going to permit an instance to send traffic with a source IP or MAC address other than its own. So that basically prevents against things like it's called ARP poisoning or man-in-the-middle attacks. This is basically where you convince another server that your MAC address is different to what it actually is, or that your IP address is different to what it actually is. So because Amazon control the host-based firewall, it prevents IP spoofing. So unauthorized port scans by Amazon EC2 customers are a violation of the AWS acceptable use policy. You may request permission to conduct vulnerability scans as required to meet your specific compliance requirements. These scans must be limited to your own instances, and you must not violate the AWS acceptable use policy. You must request a vulnerability scan in advance. So this scanning, unauthorized port scanning, this is definitely an exam question. This came up on my exam as well. So you're not allowed to do it by default. You basically have to request permission permission before you do this in advance. So they do allow you to do vulnerability scans or to do port scans, but you have to give them notice in advance. When we look at the different AWS credentials, so you've got passwords, so you've got the root account, and then you've got identity access management users. So we did that in the very first section where we set up different identity access management accounts. We then configured multi-factor authentication using the Google Authenticator app on my phone, and then we looked at access keys. So we looked at how you could access an S3 resource using access keys. We've also talked a little bit about key pairs, so that was a similar case where we're accessing EC2 instances using different key pairs. We've talked a little bit about X509 certificates, but they're just simply a way of ensuring that a link that you send out, so typically this is the way you would secure something like CloudFront. You might want to send a video to a colleague of yours, but you don't want that to be publicly accessible, but you do want them to to be able to access it and utilize the CDN. So you can basically make sure that that video is only being able to be viewed by the person that you send the link to using X509 certificates. We didn't do that as a practical example because you don't really need to know how to do it. You just need to know that it is possible to secure content through CloudFront using X509 certificates. The Trusted Advisor service, this can come up in the exam, and if you just go into the EC2 console, you'll be able to see this. In fact, I'll probably just do it after this slide. So the Trusted Advisor inspects your AWS environment and makes recommendations when opportunities may exist to save money, improve system performance, or close security gaps. It provides alerts on several of the most common security misconfigurations that can occur, including leaving certain ports open that make you vulnerable to hacking and unauthorized access, neglecting to create IAM accounts for your internal users, allowing public access to Amazon S3 buckets, not turning on user activity logging such as CloudTrail, or not using multi-factor authentication on your root AWS account. Now, the solutions architects who work for Amazon used to go around and do this as a service. As a part of their review, I think it was a few years ago, they looked at automating this, and this really sort of automated a piece of their job so that they didn't have to do this for all their customers. So this is a thing that you can look at in the portal. And I'll just quickly show you this. So it's Trusted Advisor service. You can click on it here. Make sure you're in the same region as where you've been doing everything. And you can see here, if you just hit the refresh button, at the moment it doesn't have any advice for me, but if I hit the refresh button, say on my specific security groups, it will then go through and check them for me, and it might come up with a list of recommendations. Okay, that's now finished, and you can see here its refresh is completed. Reload to see the updated information. So if I just hit reload, and it's giving me, saying 3 of my 9 security groups allow unrestricted access to a specific port. So, and if I drill down, it will then give me a list of the security groups that are responsible. In fact, look at that, it's even checking different regions, and they're all open on port 22, so that is a security risk. Okay, and I'm just going to end part 1 of the lecture here. In part 2, we'll continue to review the Overview of Security Processes white paper. Join me if you can. If not, thank you.